Hello students, this is Devarchana Raut, lecturer in computer science. In our today's lecture, we will continue with the operations on linear array. We will be discussing today the deletion operation on linear array, that is deletion at the beginning of the linear array. So let's start. At the very first step, we already know if it is a deletion operation, we need to check that is there is any element or any data present in the linear array so that we can perform delete operation on it. So for checking that, the first step we need to do in each and every deletion operation, either it may be at the beginning of the linear array or at the end of the linear array or at any location of the linear array. At the very first step, we have to check if the upper bound is equal to null. That means if the upper bound is null, there is no data element present in the array and we cannot perform the delete operation. If the upper bound is equal to null, then the linear array is empty. We will print underflow and we will exit as we cannot perform any delete operation. If it does not satisfy the condition that upper bound is not equal to null, then we will be running the second step. In second step, we have taken one variable k and assigned it to the lower bound. So in second step, k is equal to lower bound. And we have to repeat the steps from 4 to 5 until k is less than upper bound. That means the k will be running from the lower bound to the upper bound, and until it reaches or it is less than upper bound, it will repeat 4 and 5 steps. So at step 4, we have a of k plus 1 value will be assigned to a of k, and the k value will be incremented by 1. So what is this process actually? The 4 and 5 process, if we barely see the process, in this the elements are been the data elements are been replaced from one location to its previous location actually. So if we have the element in a of k plus 1 position, it will be bagged or it will be assigned to its previous location, that is a of k. So in this way, the very first element will be deleted, or the very first element at the very first element position, its second element value will be upgraded. So let's see, and how long it is going to continue. It is going to continue from the lower bound to the upper bound position. So the 4 and 5th step are to assign the value of one linear array to its previous location. So at the 4th step, we have a of k plus 1 value assigned to a of k. At the 5th step, we have incrementation of k value, that is it was first starting from lower bound and it is incremented by 1, and it will just continue incrementation until and unless it reaches the upper bound. Once it reaches the upper bound, at that time it will stop replacing the data items. So after this variable k reaches the upper bound position, then a of upper bound will be assigned as null and the upper bound will be decremented by 1. As the deletion operation has been performed at the beginning of the array, so upper bound will be obviously will be decremented by 1. So the actual upper bound has been set to null and the upper bound position has been decremented by one position. So for example, we have four data elements in the linear array and we need to delete the first position or the first data element in the linear array. So what we need to do? We need to do that the second position element will be shifted to the first position, the third position element will be shifted to the second position, the fourth position will be shifted to the third position, and the fourth position finally was, as there were four elements, the fourth position was the upper bound position, but as the fourth position data element has been shifted to the third position, so fourth position has no value. So what we need has the replication of the value of the same value. So what we need to do, the fourth position, which was the upper bound position, that was set to null. After setting it to null, the fourth position is still the upper bound position, but the fourth position do not have any data actually. So what we need to do? We need to decrement the upper bound position to its previous position. That is why it has been decremented by 1. This is how we delete. After decrementing the upper bound position by 1, our work is over. We need to stop and exit out. So this is how we do deletion operation at the beginning of the linear array. Here we have the second algorithm, that is deletion operation at any location of the linear array. So let's start with the very first step. We need to check that is the linear array empty. So for checking that, we have if upper bound is equal to null. If it satisfies the condition, then the linear array is empty and we need to print underflow and exit. If it does not satisfy the condition, then we need to come to the second position or second step, that is read the data. So first we need to read the data that we actually want to delete. Next, at the third step, we have set a variable k to the lower bound and repeat the step 5 until we reach actually that location or that data position we want to delete. So we have set k as lower bound. That means the k will be starting from the starting of the array list and it will go on checking or it will go on a search for the data we want to delete. So for that we have the condition while a of k is not equal to data. If it is equal to, then we will be repeating steps 7 and 8. If it is not equal to, then it will repeat step 5. Okay. So a of k, so k actually starts from the lower bound. It will start on checking if a of k is equal to data. If it is not, then it will increase the k value by 1. That is, the first element is not the data, it will go to the second element. The second element is not the data we want to delete, it will go to the third element. Third element is not equal to the data, it will go to the fourth element. The fourth element is not equal to the data, it will go to the fifth element, and so on. If the sixth element is equal to data, then it will not repeat step 5. What it is going to do? It is going to step 6. So what does step 6 say? The step 6 is to repeat the step 7 and 8 while k is less than upper bound. Okay, so here from step 6 to step 11, we will mark all those steps that we have already discussed in the algorithm of deletion at the beginning of the linear array. So what we need to do, that from that position onwards, from that position means from the data we want to, first of all, when we will reach the data, after that what we need to do, from that position to upper bound, now k will replace the values. What it will do? It will assign one location's value to its previous location. Again, it will increment the k value by 1. Again, it will replace one position's data to its previous position. Similarly, as we have done in deletion in the beginning of the linear array. So basically what happens, for example, there is a linear array of size 4, let's say, and the data I want to delete is at second position, right? So there are 4 elements, 1, 2, 3 and 4, and the data I want to delete is at second position. So what happens? First, the k starts from the lower bound and it goes on checking that at which position the data is there. Okay, so a of k is first of all 0. So obviously at the 0 position it is not there. So a of 1 position is the second position of the linear array. So if 1 position is equal to data, so it will not increment the k value by 1 anymore. It will come to step 7 and 8. So what is it's going to do? Now k value is equal to 1 and upper bound value is equal to 3. Okay, there are 4 elements I have already told, and in array it starts from 0, and if there are 4 elements from 0 to 3, the linear array are been indexed. Now the k value is 1 and we have found the data. Now what it will do? It will, from that step only until the upper bound position, now the k plus 1 value will be assigned to a of k. So my k was actually 1. Now a of k plus 1, that is a of 2 position data, will be assigned to a of 1. A of 3 position data will be assigned to a of 2. Okay, so now a of 3 position is the last position. So we have already reached the upper bound. So a of 3 position will be now set as null, and a of 3 position was the upper bound position. Now it will be decremented to a of 2 position. So 2 is now the upper bound position, right? So already at that location the data has been deleted and the first element would be there only, the second element has been deleted, and the next element's data has been replaced to that position, and the next last upper bound data has been replaced to the previous position. So this is how deletion at any location is been done in linear array. Next slides we will be discussing about algorithm for deletion at the end of the linear array. So this much for this slide. Thank you.